Thanks, Kerry. So my name's Adrian Topham. I think a lot of you have already met me. I work for the Crown Estate as a senior technology manager for CCS and hydrogen. My background is chemical engineering, petroleum engineering, reservoir engineering, which is why I'm kind of here, I guess, as a part of the subsurface community. And I find myself in the unusual situation of working for this very austere and interesting organisation, the UK Crown Estate, which is probably relatively unique in the sense that it owns the seabed all around the UK and therefore is the leasing body that allows access for storage. So we're not the regulator. The North Sea Transition Authority is the technical regulator, but we work very closely with them and we try and make it all happen. So I'm going to talk to you about essentially three or four things: the Crown Estate's role, um, our role in spatial management, in particular, licensing and leasing in the associated countries that Daniel just mentioned, the UK in this case, and to emphasize why spatial management is so important in the offshore. Obviously, you've talked a lot about onshore, the difficulties of doing storage onshore, but there are some issues with offshore that need to be addressed. So a few nice pictures to start with, because it's always good at the first thing in the morning, isn't it? So wind farms offshore, there's an example of one, of which there are many all around the UK's waters, and I'm sure in many other parts of the world too. The Crown Estate's role in leasing offshore wind is obviously a critical part for the UK, and is part of the way that we head towards net zero. Carbon storage, hydrogen, etc., storage, etc., are another part that are going to help us towards that decarbonisation journey. But hand in hand with that, we've got a delicate marine ecosystem that we want to protect and maintain. And my colleagues, the marine scientists that I work a lot with, love taking photographs such as these, which is a beautiful photograph, but it does show the importance of protecting our marine environment. And if we can do as much of our industrial energy work in the same brownfield sites, so to speak, then the better. So nature and environment is a key part of what we do, protecting that. So then moving on to CCS and offshore wind and putting the two together. Forgive me for not knowing what that platform is, but it looks like a producing gas platform rather than it's definitely not a carbon store in the UKCS at the moment. We have this body that we've put together called the Offshore Wind and CCS Co-location Forum, which is to enable those two sectors to work effectively together. More of which I'll tell you later on. So seabed management. The Crown Estate strategy. I'm not sure that I want to go through this in great detail. We get a lot of corporate strategies, but essentially, as I've already alluded to, it's managing biodiversity, energy needs in order to meet net zero is essentially what it boils down to in the marine environment. And in order to do that, we have various roles in both stewarding all of the different sectors that exist in the offshore. So I mentioned wind, I mentioned carbon storage, hydrogen's another one to come along eventually. But in the meantime, we've got a lot of marine aggregates and minerals extraction. There's a lot of pipelines and cables, some of those oil and gas related, some of the cables related to wind farms, but a lot to do with interconnectors between Europe and the UK. And there's several other sectors that I'm forgetting at the moment, but quite a lot of seabed use. It'll come back to me. Okay, so TCE's role, as it's sort of put in the bottom of that image, is threefold. It's getting us towards net zero, delivering a thriving marine environment, which I've already mentioned, and also yielding an economic return, which Daniel mentioned a moment ago, because none of this happens without it being feasible. Either the government pays for it or the companies want to pay for it in order for some kind of return. The Crown Estate is not different in that respect. We're a commercial organisation, and the money goes back into the treasury. So effectively, that's another part of our mandate is delivering value for the nation. So as it says in the bullet points there, it's an increasingly busy space. We're trying to coordinate across the multiple sectors that I've mentioned before to deliver the policies of net zero and nature. And we want to do this through something we call the Marine Delivery Route Map, which is a new initiative that started about a year ago. We're working on with our partners. So what is the Marine Delivery Route Map? It's essentially going to be an interactive platform to try and look at all of these sectors and understand what the art of the possible is. So in order to meet all of the many targets for all of the different sectors, how could it be done in a spatial sense? So it contains a whole series of maps and images and basically enables the ability to play lots of what if scenarios. And we can't do this alone. Crown Estate doesn't have that jurisdiction, but it's working very closely with a range of partners across UK, including the different government departments, the technical regulator, and the Sea Transition Authority, and all of the developers in the space of all the different sectors. So this is something that will be, going back to our theme of today, public data. This will be something that will be available from the Crown Estate, available for everyone to access as it develops. Excuse me. So putting it another way, there's a detailed report on our website all about the marine delivery route map, but it shows the context, as I mentioned on the left, which are the nature, environment, and energies perspective. It talks about our evidence base because the Crown Estate has a lot of data in terms of what sectors are where and what the targets are to meet them. And we have this kind of beehive hex, 1 kilometre hex grid of the UKCS. And then we try and look through different ways of managing that spatially in order to meet those goals. And on the right, as it shows the outcomes in order to achieve those different sector aims. So let's talk a little bit about CCS in the UK sector. This is another interesting image. I think it shows the way that we've been doing the licensing of carbon storage in the UK and shows the roles of the different parties. Now, I would say this is not entirely complete. Going back to Randy's comment yesterday, the myriad group of actors and bodies involved in this space is enormous. And that's an unfortunate consequence of the fact that we're dealing with a more complicated sector than we've dealt with before from a subsurface perspective. We like to think we know what we do know what we're doing as a subsurface community, but this is now interacting with an awful lot more stakeholders than, say, was the case for oil and gas extraction. So the Crown Estate's role there across the top, if we look at this in a project sense, this is talking about the appraisal term of 8 years, the operational term of, say, 25 years, post-closure period of, say, 20 years. Crown Estate's role is in offering storage, exploration, and appraisal agreements to enable appraisal, and then moving through an agreement for lease and a lease. It's basically a lease option and a lease. In parallel with the North Sea Transition Authority's carbon storage licenses, of which there are 28, or numbered to 28, there are actually 27 in the UKCS at the moment. The other government bodies, Ofgem, which is the economic regulator of government, offers an economic license, and the various marine management organisations in England, Wales, and Scotland offer marine licenses. And this is fairly similar between the two Crown Estates because the Crown Estate Scotland that looks after the jurisdiction to the north, but it's essentially very similar. Across the bottom of the phases of appraisal, which I'm sure Owen will talk more about as he goes into data needed, the North Sea Transition Authority has got a very comprehensive guideline on what is required through the different phases of appraise, assess, define, and execute before getting to operation. And it's very diligently observing and analysing those of the first two Track 1 projects, the HyNet project that Ian and I mentioned yesterday on the East Coast, British East Coast, and the Endurance project, Northern Endurance Partnership on the West Coast. So talking of those, here you can see a very busy map just showing essentially just two sectors, just wind and CCS. It always looks very busy because everything is done in a very orthogonal geometric fashion by the North Sea Transition Authority. So all of their carbon storage license areas in the boxes shown with the carbon storage license number are shown on a north-south grid, and so they tend to have those lines. That's not showing the geological structures that those carbon stores are targeting, which are obviously somewhat smaller in many cases and quite different shapes. The slightly less regular shapes come from my organisation, which awards the wind farm leases, and they haven't followed the same grid system, unfortunately, and they are, sorry, I shouldn't say that, but it does tend to make the game of Tetris a little more interesting. But essentially, they're put in place for a very good reason. The wind companies have looked at where the best foundations are, where the best wind is, so they're designed in that way. So instead of it being driven by the geology, it's driven by the energy capacity of that area. And the green lines are all the cable routes, or some of the cable routes going to those wind farms. I'm not showing on here the pipelines that go to all the existing oil and gas fields that are in a lot of that space too, which makes it very busy and complex. So that's the southern North Sea, so the west coast of the UK. This is the East Irish Sea, so on the sorry, I forgot the wrong way around on the west coast. I get my east and my west the wrong way around. Sorry. This is showing the HyNet area on the bottom side of this, which is the existing Track 1 development and the Morecambe one to the north. But again, surrounded by a lot of existing wind farms in the darker purple and ones under development in the lighter blue, I think that's what we call it. No, not showing the cable routes on that one yet. So a very busy space. So data and evidence, purpose of today's session. CO2 Stored was a project that the Crown Estate and a range of other bodies, UK Research and Innovation, the National Environmental Research Council, part of UKRI, and Energy Technology Institute put together with the help of the BGS, British Geological Survey, which did all the work pulling this together. And as you can see, a huge body of UK universities and other players and organisations fed into that. Again, as was pointed out yesterday, it's not perfect data. This is the thing that ultimately led towards the 78 gigatons, but it's very much a high side potential of the UKCS and requires an awful lot more verification in order to get to the numbers we need. But it's an example of a public database that the Crown Estate helped to support the British Geological Survey put in place. Going back to the co-location forum, his two other projects, which are also available on the website. One was the spatial characterization report, which came out of the co-location forum that basically took a lot of that data and looked at where the two sectors are likely to be placed and are being placed. And then the measurement monitoring verification report, which was done largely by the North Sea Transition Authority, but under the co-location forum auspices, is the one shown on the right. And that diagram is worth a study. It's available on the North Sea Transition Authority's website. It's linked from the co-location forum website link, which I'll share at the end. And it talks about where towed streamer seismic, 3D seismic is possible and likely to work, and going back to Elodie's presentation yesterday, and where it's not for different geological situations. And the reason that's so interesting, of course, is because of the implications it has for seabed obstacles, if I can call wind turbines that. So there's two other projects that the forum is also going to be putting into the public domain. And I should say that the forum is not just the Crown Estate. It's Crown Estate, North Sea Transition Authority, two UK government departments, marine management organisations, and two trade bodies, one for carbon storage and one for offshore wind. So it's a fairly broad group. We've commissioned and paid for these other two reports. The one on the left, the University of Aberdeen, is about to complete in the middle of this year and will be, excuse me, publicly available towards the end of the year, is looking at the subsurface aspect of co-location between the two sectors and how that might be possible, particularly the monitoring needs for the different aspects, which I'll come on to in a moment. And the one on the right is about to be kicked off, is a coexistence study looking at the issues surrounding the two sectors above the sea floor, essentially, in the operational space, which will involve a lot of the developers, we hope, in that, and providing data and evidence and experience to that project. So the other thing I should mention, talking about public databases, the Marine Data Exchange, which is the Crown Estate's data repository, which is accessible to anyone, stores all of our marine data and evidence that all the developers provide us with as part of our leases. Now, it's subject to the usual commercial constraints of that data doesn't become available from day one. It becomes available at the points in time which it ceases to be too commercially fragile, but is then essentially open to everyone. And the North Sea Transition Authority has a kind of parallel database called the National Data Repository, which has a lot of the subsurface data. The Marine Data Exchange, the MDE, has a large amount of subsurface data, but tends to be the shallow or wind-related data. The NDR, the North Sea Transition Authority's one, tends to cover the deeper data. And we are working together to make sure we don't ask for duplication from developers and that the data goes into one database, not into two. So that is definitely a key part of that. Okay, how much time? 2 minutes, right. Okay, co-location. Right, this is the interesting bit, I think. This diagram, measurement, monitoring, verification. People here from the subsurface community will be very familiar. Conformance of where the CO2 is going in the target rock formation, the reservoir. Containment monitoring of where it's going in the storage complex, and then confidence monitoring of baselines, etc. In the above that. Essentially, that's well known to this audience, but believe me, it constantly has to be reminded of all the other audiences I talk to because they're not as well versed in the subsurface as you are. Unfortunately, it's an onshore picture. It doesn't apply for the UK. It's all offshore. Now, these are my cartoons to try and talk about the art of the possible between wind farms A, B, and C here and carbon stores 1 and 2. Now, you can see different scenarios of overlap here. In the case of A, it's just an overlap with the carbon storage license area, not with the structure. Not a problem. Well, once we sort out the commercials and the legals, but not a problem technically. B, yes, you've got a cable going over a carbon store. Again, not a problem. As long as you put the drill center away from that and your monitoring area can go over that cable, which it can, not a problem, apart from the legals and the commercials. C, slightly more problematic. This is, you've got the cable issue here, which is maybe surmountable, but where you can see that the wind farm puts turbines above the carbon store, you have got a challenge. And I'm going to re-show this picture in different guises coming further forward. If we put the monitoring area on the two carbon stores as those dotted hashed areas where you're maybe wanting to do towed streamer seismic, or if it's not applicable, some other form of monitoring technology, which is very important that we look for, that's okay. And you can put your drill centers away from those cables and pipelines, which is doable. However, you still have, in the case of wind farm C, this issue to get over of how do you monitor that area if you've got closely spaced turbines. So if the carbon store's there first, sadly not the case in most instances, it's the wind farms that are there first. You come along with a wind farm, then obviously you wouldn't want to site those wind turbines, the yellow dots, over that carbon store. But maybe by then you've done your baseline surveys of your carbon store, and you maybe find other ways of monitoring that part of the plume movement. If, on the other hand, it's like it's more often the case, looking at the temporal coexistence aspect, and the wind farm's there first, along comes, it was always there, the geological storage unit suddenly gets designed as a carbon store. You then have this problem with the same wind turbines. So the area that we're now working on is trying to encourage different monitoring technologies and talking both to the developers and the regulator about how we can do that monitoring going forward where there is overlap. I think that's the last slide. Thank you for your attention.